Have you ever been in this situation? Your eyes have been glued to the computer all week, and everything starts to turn into nonsense. So, you decide to go for a walk to clear your head. In the middle of your walk, you receive an urgent message from your boss. They've realized you aren't showing as online. In this tutorial, I'm going to show you how to avoid this embarrassing situation by using the servo component to create a mouse mover using VM. First, let's go over the hardware and tools required for this project. We'll start by testing our servo in the VM app. This helps us ensure that the component is properly connected to VM and allows us to test its parameters. Connect your servo to the board using this wiring diagram. Attach your servo wheel or arm to the servo. Plug in your board to its power supply, then turn it on. Pause this video and head over to the VM documentation and follow the instructions to install the Raspberry Pi OS as well as the VM server. Resume this video when you're finished with these steps. Our robot is live. Click on the Config tab to add your components to the robot configuration. First, create the board component. For name, give the board any name you want. I used local. Select the component type board. And for model, select Pi. Then add the servo component. For name, I used FS90R. For type, select servo. And for model, select Pi. After creating the servo component, we get a bunch of options for attributes to add. This is where we tell VM where the servo is connected to. In the Attributes section, add the board attribute and set it to the name that you chose for the board. Then, add the pin attribute and set it to the PWM pin we attached the servo to earlier, which is pin 12. In the Depends On section, click the drop-down box and select the name of your board. Don't forget to save your config. Let's learn more about how to control the servo in the VM app. Click on the Control tab. Stop the servo with the Stop button. Notice how when you tell the servo to go to a higher negative angle, the faster clockwise it goes? On the opposite side, if you tell the servo to go to a higher positive angle, the faster counterclockwise it goes? Now that we've confirmed our hardware is working with VM, let's control how the servo moves by using the VM Python SDK. Open the terminal on your board and make sure that you're SSH'd into it. Because the Raspberry Pi OS Lite doesn't come with pip, we need to install it. You can check if pip installed correctly by running this command. Now you need to install VM's Python SDK. Once that finishes, head over to the VM app. Click on the Code Sample tab. Be sure that Python is selected for the language. Copy the code sample. Open the terminal on your board where you're SSH'd into. Make a directory and name it whatever you want to. I named mine mouse folder. Create a file using Nano and the Python extension. You can also name this whatever you want. I named mine anyname.py. Paste the code sample you just copied from the VM app. Save the file and close it. Run your new file. This shows you the communication status between VM and the board. No errors here, so let's continue. Head over to the Mousemover GitHub repository. Copy the sweep.py code. You can create a new file to put the sweep.py code into, or modify the file we created previously while testing the connection between VM and the board. For this example, I created a new file called sweep.py. Paste the code. Then replace these placeholders with your own robot's secret and address. This can be found in the Code Sample tab. Save and close this file. Run your file. The servo should be moving randomly in both directions. Which statement in the code we just ran is responsible for moving the servo? It's the .move API method. How do you find more API methods? The servo documentation has more API methods and even example code for how to implement them. There's also more information on how to use the config with the servo component. Before building the enclosure, turn off the board. Find a suitable box that has a size that works well for your servo. It may need some modifications. The servo with the wheel or arm needs to be just barely under the level of the top of the box in order to leave some room for the cardboard circle that will be attached to the wheel or arm. Secure the servo inside the box. Cut a hole for the power cord. Rewire the servo and put it back into the box. Find the way that works best for you to create a circle in the lid of the box with the middle of the servo being the center of the circle. I did my best. Cut the circle out and tape it to the servo. Plug in the board and turn it on. Well, that's not what we want. Let's fix it by installing what I call baby gates on the sides to keep the mouse on track. Let's test it again. Thanks for watching. I'll see you next time.